Today's lesson will be 12.6, which is Principles of Counting. We'll be working on three objectives, which are applied fundamental principle of counting, count permutations, and count combinations. Let's start. Let me open the slides for you. We're going to explain on the slides. Whatever I need to add, I'm going to add it as a note. It's this one. Okay. Let me double check that all the slides are here. Yes, it's this one. Let's start. The first one, I'm going to maximize the graph. Okay, great. So the first one, we will be discussing fundamental counting principle. You want to choose your outfit. You have two options, a blue jeans and a black jeans, and you have three tops, a white, a yellow, and a blue. So if you want to go for the blue, you have three ways to wear or three different colors to choose. You have a white, a yellow, and a blue. And if you want to go with the black, you have a white, also a yellow, and a blue. So in total, the total options or outfits that you can choose from will be 6. Now there's another way, instead of doing the tree diagram, this one here we call it tree diagram. There's another way, which is you simply multiply. You simply multiply the options for your first event, which are 2 jeans, with the options of your second event, which are the colors of your shirts, which are 3. So by multiplying 2 times 3, you're going to have 6 outfits, and you want to choose from them. But in total, you're going to have 6 different outfits. As a definition, if you can choose one item from a group M items, which are the jeans, 2 you have, and a second item from a group N items, which are the tops, 3 colors, then the total number of 2 items choices, let me here underline the word total. So here, the total, this is what I'm working on, the total amount or number of 2 items will be M times N, which is, in this case, it's 6, which is here. This is the first rule that you need to pay attention to, which is fundamental counting principle. You have many events, you have many choices for every event. For each event, to find the total answer or the total number, you just multiply them. Let's erase these and go to the next one. Okay, now this is the second one. Let's work on another example. Considering you want to buy a car. This is the car. So same thing, you have 2 body styles, a sedan and a hatchback. You have 5 different colors. This is the first event. So this is my first event. Let me underline it here. So here, this is your first event. This is your second event, which are the colors. This is your third event, which are the 3 models. So as the basic one, as we discussed before, we're going to multiply them. So this is going to be 2 times 5 times 3. So the total will be here, if I want to just put the total, you're going to have 30. So if I'm going to multiply 2 times 5 times 3. And the total will be 30. I have 3 events, and for every event here I have 2 choices. Here I have 5 choices, and here I have 3 choices. If you want to check here the tree diagram, it's the same thing, which is here at the end. My new car, I have an option, a sedan and a hatchback. I have 5 colors. I can choose black, a sedan with a black color with a GL, or a sedan with a red color with an SL, or a hatchback with a green color with an SS. So the final line here, or the final column that you're going to have here, it's a column, here it's a line. It's going to be the total choices that I can choose from, which are 30. Same thing here. Let's also discuss this one. Before, let me erase these. Okay. Also the same explanation or the same concept, counting outcomes. This is a team, a football team. You have 3 events, the jerseys, the pants, and the shoes. So for the jerseys, I have 3, which is the red, the white, and the gray. For the pants color, I have 2, gray, black. And for the shoes, also I have 2, black and white. So the total will be 3 times 2 times 2. The total will be 12. Or you can simply count here the last one, which are the last options. It's going to be red, gray, black, or red, gray, white. Red, black, black, or red, black, white. White, gray, black, or white, gray, white. This is how, these are your options, which are 12. Let's continue. Hopefully everything is clear. Don't forget, whatever you need to ask us, we are always ready to answer all your questions. Now, this is the rule. The fundamental counting principle is a method to determine the number of ways multiple independent events can occur. If you have many events, and for every event you have A different ways, A1 ways, A2 ways, and AN ways, the total number of ways will be multiplying how many options or how many choices you have for each event, which is A1 times A2 times AN or A3, or you keep on continuing. Here also it's another way, which is the tree diagram. The same concept. For example, you have one event that you have 2 events. The first one has 4 options, and every option has 3 different options. You just multiply them. Let's start now with this example. This is an extremely important question. Let me repeat here something just to make sure to explain for everyone. These exercises that you are working on, you have similar ones in your books. If they are not the same, they are similar. That's why it's going to be much easier for you to connect things. A computer password must have 3 letters followed by 2 digits. So here, directly, I'm going to start. This is my password. Letter, letter, a third letter, a digit, and a digit. Now they are telling you that in how many different ways you can put your password. Here, pay attention. Of course, you already know that to put the password, the order does matter here. So I'm just going to put, to make my work much easier, I'm just going to put the lines. You already know that we have in total 26 letters. So we already know that in total we have 26 letters. And digits, we have 10 digits. So I am choosing, I have 26 options, 26 choices for the letters and 10 choices for the digits. These are my events here. I'm going to put them here. The first place is my first event. It's a letter. So I have a choice to put one out of these 26 letters. So I have 26 option or 26 choice times, because I'm doing it now. The second one, because they said no restriction, so if I put A here, I can also put an A here. So I still have 26 options or choices again. And same thing for the third. No restrictions, so I can put also another number here, which is 26. Now for the digits, the 4th and the 5th should be a digit. So it's going to be 10 here and 10 here. This is the work here. If you want to see it, they just did the same thing, and at the end, this is the total number of passwords that you can make. The total number of passwords that you can make with these or this coding or this given the givens. You have 5 places. The password is made of 5 places. The first 3 are letters, and the 4th and the 5th are digits, and we just made it. And pay attention again, no restrictions. Now for the second one, what did they say? No letter or digit may be used more than once. So here, this is a good one. I'm going to underline it, so you're going to pay attention to it. No letters or digits are used more than once. What does it mean? It means that the letter that you put in the first place, you can't put it in the second. So my options are decreased by 1. Same thing here. The letter that you put here, you can put it in the third. So also again, it's decreased by 1. So let's do it here and check the work later on. Same thing, I have 5 places for my password, 3 letters and 2 digits. The first one, 26, because I am choosing my options for the first one are 26. Because we said no repetition, so I'm going to have 25 for the second. Because they said can't be repeated, I'm going to have 24 for the third. Same thing for the digit. The first place here, because you didn't use any digit before, it's going to be 10 choices. I have 10 choices. And for this one here, it's going to be 9. By multiplying them, we're going to get the final answer, which is mentioned here exactly. The number of letters is decreased by 1 for each letter in the sequence, and same thing for the digits. Hopefully it's clear. Let's continue. I'm going to erase these. Okay. Here and here. Now let's continue to the next slide. An exam contains 4 true or false questions and 6 multiple choice questions. Each multiple choice is made of 5 possibilities. Let me this one here fix it, and I'm gonna put 4 possibilities. It's 4 possibilities. So 10 questions, I'm gonna put 10 lines, which means 10 events. 3, 4, 5, 6, 7, 8, 9, and 10. 4 true or false. So when we say true or false, which means you can answer true or you can answer false. So you have 2 choices for the first. And the second, same thing, because they said the first 4, and the third, same thing, and the fourth, same thing. Now the next 6 questions are multiple choices of 4 possibilities. So for this event, I have 4 answers. 4 possibilities of answers. Same thing here. Same thing here. The same thing for this. The same thing here and also here. So by multiplying these events, because you have events and these are the possibilities of each one, we're going to have, you can write it also like that, which is 2 to the power 4 times 4 to the power of 6. And you're going to have the final answer. Let's check the solution here, which is the same exactly. And you put the final answer. This is the number of ways to answer this exam. Let me give you 2 minutes to relate things together. You always connect them. You always read the question. You have events. Multiple choices for every event. What are the options that I have for every event? And you continue. Let me erase to continue now for the next. Okay. Now till now, what we are saying is what we worked on which concept? I have events, and I have choices. And I need to find what's the total amount or the total choices that I have. Now let's start this thing. Permutations. We're going to give you 3 letters, A, B, C, and A, B, and C. And permutation means in how many different ways you can place these letters. And of course, order. Permutation, always keep that in mind. Order matters. So I'm going to put it here. Order matters. Because if you want to read ABC, it's different than ACB. It's different than BAC. Order does matter. So let's try to check how it's going to be. I'm going to give you 2 different ways. The first one, if you want to do the whole work and you want to analyze it. The second one is the better one, the one that we're going to use. Because here we just gave you 3 letters. I might give you 4, I might give you 5, I might give you 10. Of course, you're not going to do all the work or the tree. So if I want to put the A first, you can put A, B, C, or A, C, B. If you want to put the B first, you can put B, A, C, or B, C, A. If you want to put the C first, you can put C, A, B, and C, B, A. So in total, we got six permutations or 6 different orders we can put. Now this is the second way that I'm going to explain it here, and we're going to connect it to the lesson. In the first place, I can put A or B or C. So I have 3 options here. Now for the second place, if you put A here or B or C, you only have 1 A. So for the second place, you will have 2 options. If you put A, you will be putting B or C. If you put B first, you will be putting A or C. And if you put C first, you will be putting A or B. Now for the third place, if I put A in the first, B in the second, I'm going to only have 1 option for the third, which is C. If you put A first, C second, I'm going to have 1 option, which is B. Let's continue the same work for the rest. If you put B first, A second, you're going to have C. Here you're going to have A. Here you're going to have B. 1 option. Here you're going to have A. Now look at these numbers. 3 times 2 times 1, which is equal to what? If you still remember, let's connect things together. This is factorial. This is 3 factorial. When I multiply a number by all the precedent or the numbers before, you're going to have 6. And from where I got this number, it's n factorial. So this is the first formula that I want you to pay attention to. When we have permutation, you have n numbers and you are shoveling them all, you are changing their order, all the n ones, formula will be n factorial. If you have 3, it's going to be 3 factorial. Let me add here 3 factorial so that it will be clear for everyone. It's 3 factorial. If you have 4 letters, it's going to be 4 factorials. If you have 5 letters, it's going to be 5 factorial. Always keep in mind, I have 3 different letters. I don't have any repetition, so this also matters. Here in the one on the side, they are just explaining it the same thing, just using a tree diagram. I'm going to keep this one a little bit for you all so you can check it. I have 3 letters, permutation, no repetition. It's going to be 3 factorial, which is n factorial. Let me erase it and check another example. Of course, when you are reviewing the lesson or studying or checking it for the first time, You're going to check all the details, whatever you need, you can stop, you can concentrate on them. You can take it as a note in front of you and try to redo it again in front of you. Exactly. Now let's check this one. What is a permutation? Check this one here. You have tiger. Tiger is made of 5 letters. 5 different letters. So you have tiger, which is made of 5 different letters. So I'm just gonna put 5 places. The first letter, you can have 5 options for it, which is T or I or G or E or R. So once you put this letter here, you can't put it again in the other place because you only have one unique letter. So the second letter, you have 4 options for it. The third, you have 3 options. The fourth, you have 2 options. And the fifth, you have 1 option for it. And by multiplying them, which is the 5 factorial, it's going to be 120 permutation. This note here, in the red rectangle, this is the reminder of the n factorial. N factorial, what does it mean? You are multiplying n or 5 by the number before it, which is 4, by the number before it, which is 3, by the number before it, which is 2 in this case, or this is the general rule. Let's continue. Same thing here. I have 4 different letters, and how many different ways you can put them? It's going to be directly, exactly as you said. I know that some of you are start solving with me. It's going to be 4 factorial, which is going to be 4 times 3 times 2. Of course, you could put the times 1, but it's not going to change anything. I'm going to put it anyway, which is the final answer, 24. Let's continue now. Here they are just putting them for you in details. Check them. This is everything. Okay, now the next slide is a little bit different. And I repeated this note many times when I was doing these exercises. Whenever we are doing the permutation, I'm always asking you, do we have any repetition in the letters? A, B, C, D, we don't. Tiger, we don't. A, B, C, we don't. So when we don't have any repetition in the letters, it's n factorial. What if we have repetition in the letters? Look here at Mississippi. It's a river in the United States. M is repeated once. First, the total letters here is 11. M is repeated once. I is repeated 4 times. S is repeated 4 times, and the P is repeated 2 times. Now, if the letters are randomly arranged in order, what is the probability that the arrangement spells out Mississippi? So in how many different ways you can use these letters to rearrange them again? So how many distinguishable permutations we're going to have? This is the rule. In parallel here, I did it here on this side. So it's going to be 11 factorial over, you are dividing. I'm going to explain why we are dividing. M is repeated once, so 1 factorial. I is repeated 4 times, 4 factorial. Here it needs to be fixed. Let me fix it. Here it should be 4. P is repeated, S is repeated 4 times, so it's 4 factorial times, P is repeated 2, it's 2 factorial. And this is the answer. Now for the ones who are checking, Miss, why we are doing this one, let me explain it for you. This is the formula here. I'm going to circle it. This is the formula, and I'm going to explain it for you why we are dividing by the repetitions here using TOT. Now TOT, it's going to be 3 factorial over, T is repeated twice, 2 factorial, and the O is repeated once, 1 factorial. And the answer is 3 times. I can write TOT in 3 different times, which is T, 3 different ways. T, T, O, and O, T, T. Now, why we only have 3 ways? Let me ask you this question. If I brought the T here, I brought the T and brought it here, and I brought this T here and I put it here, would you have a different spelling? Of course not. If you shuffled the places of these 2 T's, would you have a different spelling? Of course not. These are, we are removing from them. So instead of having 6 ways, I'm removing the repetitions that will give me the same pronunciation. And here, if you shuffle the T's here, won't you have the same spelling? Yes, you will. That's why here it's 3 factorial or n factorial over the factorial of every repeated letter or the repetition of every letter. Hopefully it's clear. Now let's continue with the next slide. Till now, we are permuting, we have n, we are permuting the n, all of them. We have 11 letters, we are permuting the 11 letters. We have 5 letters, we are permuting the 5 letters. What if they ask us that? How do you calculate the number of permutations of n objects taking r at a time? This is now the next concept, which is the permutation that we're gonna work on. So we have n objects, and you are taking r at a time. This is the formula that we're gonna work on. NPR, which is n factorial over n minus r factorial, which is, here you are picking r of the n objects. So I have a total of n. I'm choosing in how many different ways you can choose r objects from it, and also putting them in order. Let's check this example here on the slide. Find the number of ways to arrange 6 items in groups of 4 at a time where order matter. They should mention for you that the order matter, because other than that we will be using another way. So here I have 6, which is n, and I have 4 at a time, which is the r. So we're just gonna apply the rule. 6p4, which is 6 factorial over 6 minus 4 factorial. You can use the calculator, which is 720 over 2 factorial, and this is the final answer. Or you can do it mental math, which is 6 factorial over 2 factorial. 6 minus 4 is 2 factorial. When you simplify the factorials, I'm going to do the work here because I think it's interesting to know this concept. It's a good thing to know these concepts. By simplifying the factorials, you're going to have, you will be removing all the numbers equal to 2 or less than 2, and you're going to continuing from 3. So it's going to be 3 times 4 times 5 and times 6. So I'm going to have the same answer mentioned here, 360. Just check the work before I continue. Now let's continue. I'm going to erase it so it won't affect the next slide. The next exercise that we're going to do are also related to permutation NPR. Let's continue. Okay, this will be the final slide for the permutation part before we continue to the combination. You're going to ask what's the combination. Also, we're going to know it. You are burning a demo CD for your band. Your band has 12 different songs stored on your computer, and you want to put it on a CD, but by choosing 4 out of 12 songs. So here, same thing. N will be 12. R will be 4. This is N. This is R. And you already know that the order of the songs will change, which means I'm going to have the order matter here. Also, I'm going to erase it and I'm going to type it. Order matters. Now let's continue. It's going to be 12p4. You just do the same thing, 12 factorial over 12 minus 4 factorial. And this is your final answer. You have 11,880 different orders to put the songs. Now here we're going to start by something new, which is permutations versus combination. The only difference between these two words is that the formula, of course, will change, and one of them, the order matters, the second, the order doesn't matter. For example, let's discuss this one. Okay. So we gave you letters A, B, C, D, and they are telling you how many ways are there to rearrange. When we say rearrange, arrange, rearrange, which means order matter here. So here I'm just going to use what? The one that we just took before, which is the permutation. It's going to be what? I have a total of 4, so it's going to be 4 factorial equals to 4 times 3 times 2 times 1, which is equal to, I have 24 different ways to choose 3 letters. Sorry, we are choosing, it's going to be here, let me just fix it, it's going to be 4 factorial P3. So it's going to be 4 factorial over 4 minus 3 factorial. It's going to be the same, but I totally gave you the answer. I want you to understand what are we doing. So the answer will be 4 factorial, because 4 minus 3 is 1 factorial. It's not going to change anything. It's going to be 4 factorial, which is equal to, I'm going to write it again, 4 times 3 times 2 times 1, which is equal to 24 different options. This is the normal one. Here they are showing you the ways. Look at it. ABC, you can write it, you can choose ABC, you can choose ABD, you can choose ACD, and you can choose BCD. Now, ABC, you can write it in six different ways. ABD, you can write it in 6 different orders. ACD, you can write it in 6 different orders, same thing for this one. So when we say rearrange, it means that order matters. We're going to choose for P3. Now here, how many different ways are there to choose? They just said choose. They didn't specify the order. They don't care about the order. They just want you to choose 3 letters out of ABC. And wherever you put them, it's going to be as 1. So let's discuss it here. Let's erase this line. Go back to the pen again. Okay. So when we say 3 elements, they didn't say any order, no order, so order doesn't matter here. ABC, the whole thing, this whole line, this whole column, sorry for that, is made basically only by 3 letters, which is ABC. If you say ACB, it's still 3 letters, which are ABC. If you say BAC, it's still 3 letters, which are BAC. I don't care about the order. Same thing here. All these are made of the same letters, which are ABD. Same thing here, are made of the same letters, which are ACD, and here same thing, which are these. So the combination here will be only these, this, and this, which is 4. Now you're going to tell me, Miss, how are we going to get this number? How are we going to get the 4? There is a formula for it. There's a formula for the combination. We're going to check it here. Let me go down, and this is the formula. Let me first erase the notes that I just wrote for the previous ones. Okay. Okay. Combination is a grouping or subset of items where order does not matter. I'm going to repeat, the order does not matter. It's going to be combination NR. N is the number of items in a set, and R is the number of items selected from the set. So NCR will be N factorial over N minus R factorial times R factorial. Now, if you look at this formula here, this part, you already know it. This part, you already know it. Sorry, it should be with the factorial. Let me just put the factorial again. It's, yes, it's exactly, this is P, this is NPR. This is the permutation. So in a way here, I'm gonna write it as a different formula. Let me put the text. You can write it like that. It's NPR over R factorial. So this is the formula of the combination. Order does not matter. I'm going to repeat what I just said. Combination, order does not matter. We are choosing R terms from N terms. The formula will be N factorial over N minus R factorial times R factorial, which is same as NPR over R factorial. Let's do a few examples for the combination before I give you the summary at the end, and that will be all. Okay. Let's do these examples. We still have 1 and 2 examples, third one, and at the end, the summary. Combinations. The student must answer 3 out of 5 essay questions on a test. Let me ask you a question here. When we give you the test, the test paper, you are free to start by any question you want. Your grade won't change if you choose to start by the last one. Your grade won't change if you choose to start by the 5th question, or by the 1st, or by the 2nd. So here the order of answering the questions won't change on your grade. Okay, so let's check how it's going to be. You have 3 out of 5. So 5 will be the N, and this is the N, and 3 will be the R. And as we said, combination order does not matter. So it's going to be 5C, 5 factorial, 3 factorial over 5 minus 3 factorial. Now here they just simplified manually. Of course, you can do it using the calculator. 5 factorial over 3 factorial, 2 factorial. Let me here also teach you this way for the ones who prefer to do it directly. If you want to simplify the 3 factorial with the 5 factorial, you will only have 4 times 3, because 3 times 2 times 1 will be removed by this one. And the 2 factorial is 2 times 1. Let me here tell you exactly what do I mean. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And the 2 factorial here, I'm gonna just make some space. Let me change the color. Green. The 2 is the 2 times 1. So when I simplified 3, 2, 1 with the 3, 2, and 1, I still have 5 times 4 over 2 times 1, which is the final answer. Same thing here. Let's also do it. Okay. How many committees of 3 people can be chosen from a group of 8 people? Miss Layal entered the class. No need any admin. Your admin entered the class, and she wants to choose 3 students out of the class. She didn't specify, or she didn't give you a specific criteria for choosing them. Any 3. Order doesn't matter. She just wants 3 out of 24, or here 3 out of 8. So it's going to be how? Okay. Let me put the draw again. So 8 people are the N, 3 people are the R. So it's 83. 8 factorial over 3 factorial, 8 minus 3 factorial. Here they are putting all the steps for you so you can understand it better. Same thing, we simplified, and the final answer will be she can have 56 different committees, 56, 3, a group made of 3 in a 56 different way. Okay? Now the next example that I'm going to do, or the exercise that I'm going to do, is extremely important. And this one, it's a little bit different, but it's so nice, because you're going to understand it. Once I start reading it, you're going to understand it. Okay. Let's go back. There are 7 boys and 3 girls in a group tennis school. So I'm going to write them here. I have 3 girls, and I have 7 boys. So in total, I'm going to have 10. In total, I have 10 students. I'm choosing 10. I have 10. Then coach must select 4 people from this group to participate in the county championship. The first question here, they're just asking you how many 4-person team. They didn't specify any condition. They didn't say any specific criteria. They don't want any restrictions. They just want to choose 4 out of 10. Order doesn't matter. He can choose 4 boys. He can choose 3 girls and a boy. He can choose 2 boys and 2 girls. They didn't specify. That's why here we use the combination. 10 is the N, 4 is the R, and here they just directly put the formula, which the answer, which is 210. Of course, yeah, we can show the work here. It's going to be 10 factorial. From where he got this answer, it's 10 factorial over 10 minus 4 factorial. Yes, and 4 factorial. So the answer will be 210. The next question, you're gonna see that we changed the concept of the question. He specified how many boys and how many girls he wants. Let's check. It's going to be how. Let me put this one here again. Erase. Let's erase these here. Okay, and let's go to the next part of the question. Okay, in how many ways can 2 boys and 2 girls be chosen to participate in the county championship? So here I am choosing 2 boys out of what? And I'm choosing 2 girls out of what? Now this is the question that you're gonna have to ask yourself whenever we have a specific condition. These 2 boys, we are choosing them out of 7. And these 2 girls, I am choosing them out of 3. And the end, we already know that it's multiplication. It doesn't matter here also, I'm choosing 2 boys out of 7. The order doesn't matter. I'm gonna put it again. Order doesn't matter. That's why we are choosing the C. So I'm gonna read it like that. I'm choosing 2 boys out of 7 and I'm choosing 2 girls out of 3 to make this team. And how many different ways I can have or I can do this team. Choosing 2 out of 7, which is the combination 7C2. Choosing 2 out of 3, it's the combination 3 combination 2, and means multiplication. You do the work and the final answer will be 63. Now let's go to the last slide, which is in a way a summary of the lesson. How do you know? You're going to tell me, Miss, how we're going to know when to choose the combination, when to choose the permutation? We have some keywords. You're going to use them. I mentioned them here. I don't know if it's clear, but as much as possible. So for the permutation, order matter. For the combinational, order doesn't matter. The common ones are number of ways selecting R times items out of N, and repetitives are not allowed. So here, the formula for the permutation is NPR, which is N factorial over N minus R factorial. Clue words, arrangements, schedule, order. For the second one, order is not important. It's NCR, which is N factorial over R factorial N minus R factorial. The clue words are group, sample, selection. Here at the end, we're going to have these formulas. Now, this part, skip it for now, because we didn't do any combinations or permutations with the repetition. I want you just to pay attention to this one, this part here, which is NCR, N factorial over R factorial, N minus R factorial, and the permutation without repetition, which is the N factorial over N minus R factorial. Now here you're going to tell me about, Miss, the examples of the repetitive letters in Mississippi and tote and these ones. It's not this formula in a way. Here, the other one, it's the N factorial over how many times each letter is repeated. Here they are just telling you that combination, unordered list of items, permutation is ordered list of items. Repetition here, I'm gonna skip it, but it refers to whether an item on the list can be repeated or not. N is the number of possible items that can be selected, and R is the number of items that we are selecting from N. This was the lesson. Hopefully it was clear. And again, I want to ask you or to insist that whatever you need to ask us, we are ready to answer all your questions. So to make things clear for everyone. And that's it. Thank you again.